Welcome to this deep dive into containerization, architecture, and cloud-native patterns as we master Docker. Infrastructure evolved from bare metal to virtual machines, and finally to containers. Containers use OS virtualization with a shared kernel and isolated user space for instant startup, offering superior efficiency. The dependency hell problem arises when environments differ or dependencies conflict. The solution is to package the application and its environment together, ensuring consistency. Docker acts as the standard container for code, much like modern shipping containers revolutionized logistics. It provides standard size, standard operations, and runs on any infrastructure. Docker utilizes Linux kernel features for isolation and control. Namespaces hide processes and resources for isolation, while cgroups limit resources like CPU and memory. The Docker file is the blueprint for assembling an image. It defines the base OS, working directory, dependencies, source code, and startup command. Best practices include using small base images and layer caching. Docker images utilize a union file system. They are built from stacked read-only layers, promoting efficiency by storing common base layers once. A thin read-write layer is added when a container starts, using copy-on-write for modifications. An image is a read-only template, a build-time artifact stored in a registry, analogous to a class. A container is a runnable instance, a runtime environment, which is ephemeral, like an object. Containers are ephemeral, so data persistence requires volumes. Volumes are directories stored outside the container's lifecycle, managed by Docker. They ensure data survives container deletion, can be shared, and offer high-performance I/O. Docker networking options include Bridge, the default private internal network, Host, which removes network isolation for faster but less secure communication, and None for complete isolation. Port mapping forwards host ports to container ports. Docker Compose simplifies running multi-container applications. It uses a YAML file to define services, networks, and volumes. A single command, Docker Compose up, starts everything. The Docker architecture involves the Docker client, which is the CLI, the Docker Daemon, a background process managing objects, and the Docker Registry, a store for images. The client communicates with the Daemon via REST API. The development workflow lifecycle involves 4 stages. Code, where you create the application source and Docker file. Build, which creates the image. Run, which starts the container. And push, which uploads the image to a registry. Essential Docker commands include Docker build for creating images, Docker run to start containers, Docker exec for debugging, Docker logs to view output, and Docker system prune for cleaning up unused data. For scaling beyond one container, Kubernetes, or K8s, is an orchestration tool that manages Docker containers at scale. It offers auto-scaling, self-healing, and zero downtime deployments. In summary, Docker provides a standard unit for software packaging. It is lightweight due to UnionFS and a shared kernel, and runs everywhere, eliminating environment inconsistency. Thank you for watching this video on Mastering Docker.